Alright, ladies and gentlemen, what we have here is a quick video on the trig ratios and the Pythagorean theorem. Remember, our trig ratios are the sine, cosine, and tangent. The sine function is always comparing the opposite over the hypotenuse. The cosine function will be comparing the adjacent side to the hypotenuse. And the tangent function will be comparing the opposite side to the adjacent side. When I write this trig reference angle sides, that's the format for all of our trig functions. Trig just means sine, cosine, or tangent. Reference angle is going to be one of the acute angles, not the right angle. And then your sides are going to be either your opposite, adjacent, or hypotenuse, depending on which trig function we're dealing with. So, as I look at this first example here, and they want the sine of angle V, V is my reference angle. Sine is opposite over hypotenuse, but I don't have the opposite, and that's where my Pythagorean theorem comes in. As long as I have two sides of a right triangle, I can use the Pythagorean theorem to find the third. Leg squared plus leg squared equals hypotenuse squared. HS is a leg, so HS squared plus 12 squared equals 37 squared. 37 is the hypotenuse. That doesn't matter what the reference angle is. I can now use Pythagorean theorem here to solve for HS. And HS is 35. So now I know all three sides of my triangle. Writing my ratios should not be a problem. Sine is opposite over hypotenuse. V is the reference angle. That's 35 over 37. Always look to simplify these ratios. If they can't be simplified, you're done. Okay. Cosine is adjacent over hypotenuse. Angle V is my reference angle, so 12 over 37. And then we would continue on. If I change my reference angle but use sine, it becomes 12 over 37. Opposites of S, hypotenuse. Cosine becomes 35 over 37, adjacent to S and hypotenuse. Tangent of V, opposite of V, is 35 over adjacent to V, that's 12. Change the reference angle. Now my opposite of S is 12. The adjacent to S is 35. None of these ratios or fractions simplify, so that's all we're looking to do.